We are going to look at a matched pairs t interval. So how do we know the difference between matched pairs and a two sample? Because a lot of times we're given two sets of data. With matched pairs, the two sets of data represent like a before and after. A person doing a certain method one time and then they do a different method the second time. So the data is like matched up, it's paired. So the information for this table would look like teenager 1, and then their parent says they spend 5 hours, and the kid says, no, I spent 8. So this one set of data in the table represents one kid. As opposed to if there was 10 values in two separate tables, that's actually representing 20 total subjects. That's your two sample. Okay. So we're going to go through our 4C method. The first C is choose. And this has now become important because we now know 5 different types of confidence intervals. We know the one sample confidence interval for the Z interval for the proportion. We know the 2 sample Z interval for the difference in two proportions. We know the 1 sample T interval for the mean. We know the 2 sample T interval for the difference of means, and now we know the matched pairs. So now the choose becomes important because we have to look at the problem and decide which method this is. So because we're given a mean and a standard deviation, we're looking at a T interval. And then it tells us, do parents realize how many hours their children are spending online? The family psychologist conducted a study to find out. A random sample of 10 teenagers, so this is your N, was selected, and each teenager was given a Chromebook and free internet for 6 months. During this time, the internet usage was measured in hours per day. At the end of 6 months, the parents of each teenager were asked how many hours per day did they think the child spent online during this time frame. The dot plot and summary statistic are for the differences, the actual time minus the parent perception. Measured in hours per day. So because there's 10 teenagers and you have the actual time and the parent perception for each teenager, that is your matched data. So we're looking at the matched pairs, T interval, for mu D, and that means the mean difference. The average of the differences, okay? And then it says 90% confidence. And then here is our parameter, okay? So the parameter can almost always be found in the question. The true mean difference in time spent online. The next is check. We have our 3 main conditions. For the T intervals, it's going to be your random or random assignment. N is less than 10% and of the population, and your central limit theorem. Is it a large enough sample? So is it normal the population? Is N is greater than 30? And if those aren't true, we look at the histogram for no skew or outliers. So the first is it a random sample? Yes, it says a random sample of 10 teenagers. So the sample was random. Why? So we can generalize. The next is 10 less than 10% of all teenagers. Yes, definitely. So we can sample without replacement. And is N, it's not from a normal population, so we're looking for a large enough sample. It's not greater than 30, so we're looking at our dot plot. In this case, it shows no strong skew or outliers. So the dot plot of the data shows no strong skew or outliers. So we can use a normal model. And in this case, we're actually using the T model. The next is calculate. Our general formula is our point estimate plus or minus the margin of error. Our exact formula, specific formula, is the mean difference, the sample mean difference. So we do x bar with a little d, plus or minus t star, and it's s, the standard deviation of the differences, over the square root of n. That's the same formula we used for the one sample t interval. We're just substituting the difference, the mean of the differences, and the standard deviation of the differences. Our degrees of freedom are still going to be n minus 1, so that's 9. So my mean is 3.02 plus or minus. I'm going to look up t star in a minute. I get 1.316 divided by the square root of 10. Now let's pull in a t table. Okay, so here's my t table. I have 9 degrees of freedom, and I want 95% or 90% confident, which because it doesn't show the percentages at the bottom of this, but in a 90% confidence interval, my tail probability is 5%. Okay, so I'm looking at the 5%, that's 90% there for my tail probability. If you had the bottom part of the table, which is in a different picture, you'd see that that's also the column. This is what the table looks like online. Hopefully they'll put it into one file. 9 degrees of freedom, and that means my numbers meet up at 1.833. Okay, so I'm going to put that off to the side. That was our t star, 1.833. Okay, and we plug that into our calculator to get our values. Okay, so I plugged it in the calculator. Notice here in my calculations, I just plugged everything in with no parentheses, and I get my two values. So I have 2.257 and 3.783. Okay. And that is in hours. That's hours. And so the last is conclude. We are 90% confident. The interval from 2.257 to 3.783 hours captures and you're repeating your parameter, true mean difference in time spent online. And the question is, does this provide convincing evidence that what actually happens is different from parental perception? And the answer is yes, because both of our intervals are positive. It's positive, positive, greater than 0. So we believe that that difference is between 2.2 hours and 3.7 hours of what actually kids are spending time online, and their parents believe they are spending online.